I know the meeting was scheduled at 9.
Hey,
Yeah.
Manali, no, that's all right. Yeah, no worries. Meanwhile, anyone has any questions, probably we can cover that if there are any questions.
I'm not sure, although I have scheduled a call, but I am not able to record this call.
I'm
So,
recording it. I'm recording it, no worries. So meanwhile, if it's all right with everyone, I would love to have a kind of an introduction. I've never had an introduction of anyone of you know. Would love to just know what you folks are doing. Where are you based out of?
Hi, Manali here. I'm based out of Pune location, and I work with Deloitte Consulting in like organization, workforce, and change practice. So we deal with the ERP transformations, and we provide change and training support to the client for the large scale transformations.
Which part of Pune?
I am from Bani, right? And I stay at Bani.
Okay.
Yeah, and the office is at Karadi.
Oh, wow. Okay. That's almost an hour and a half drive.
Yeah, almost like if you leave early, like around 8:15, then you can reach in 55 minutes,
Yeah.
or else it's 1.5 hours.
Yeah. How about others?
This is Gauss here. So I'm presently stationed in Bangalore. I take care of brand decathlon, the India production of the garments and textile company
Nice. Which part of Bangalore?
in Yelahanka near the airport.
Okay, Yelahanka. Okay. Nice.
Hi Anup, this is Prachi. I am also based out of Pune location. So I work for Hindalco, Aditya Birla Group,
Okay.
and I am in new product development.
Nice. And again, which part of Pune?
I stay in Moshi. My plant is in Jharkhand. So
You stay?
Moshi.
Moshi.
Pimpri
Okay.
Chinchwad.
Okay. The lake near. Okay, got it. Yeah.
Hi, Anup. This is Samula. I stay in Kolkata. I work with Deloitte South Asia. I'm into consulting since 10 years. So
Nice.
working majorly technology and AI and data side of it, engineering AI and data.
Okay.
That is my profile.
Nice. I mean, I had a difficult. I have a fetish for names and multiple things, but names, including I had most difficulty with pronouncing your name. I, you know, I mean, and Bengali names are tough for non-native speakers, right? For example, I have a friend called Konkana, and I could not figure out. She would write Kankana, and for almost 2 years I struggled how to pronounce her name. Till she told me it's Konkana, it's not Kankana. So your name is also. I hope.
Yeah, it is. It is Bengali name.
Bishas. I hope I pronounced the Bishas part right. So I did my 1 year finance course from IIM Calcutta after doing the IIM Kozhikode from Joka.
Oh, in Joka.
In Joka, yeah, in Joka.
Yeah.
And I have a fetish for places also in traveling, so that's why I'm asking where because I'm familiar with these places.
So, in case if you visit sometime in Kolkata, do let us know in the group. So maybe
Absolutely.
we can connect with you.
Absolutely. And Kolkata is a very active EPGP community actually. You have Bhaskar Chaudhary, who's I'm not sure whether you.
Okay.
Yeah, Bhaskar Chaudhary is the chapter head. So very nice guy.
Oh. Yeah, we haven't got this. I mean,
Yeah, you're
so
very new. You'll get to know in some time. Yeah.
yeah.
How about others? I'll probably just wind up because I hope others join. That it was. How about others? I have a namesake. I hope others really join because are they waiting for to be let in or something? Oh yeah, okay. A lot of people have just joined.
Yeah, they are joining.
Yeah.
Yeah, I got entry, Manali. Thank you.
Yeah, no problem. Shush. Nadi. Almost all have been active.
Hi. So I think let's probably get started. People will continue joining. I hope my screen is visible to you folks. I'll be walking through some stuff that was asked. Can someone go on mute?
Mahesh, can you please go on mute?
All right. So there are certain topics that were shared with me. This was shared by Monali. So Monali, I'm not sure whether she has joined or not.
Yeah, no, I joined.
Okay. So I will be covering this in an order which I feel is better to understand. We'll be starting with probably the first part of it. Feel free to intervene anytime you want me to explain something. There was a couple of separate pings to me saying that is it okay to ask stupid questions, and the normal answer is no question is stupid. Please feel free. Absolutely, this is not about it is about learning, right? So just feel free to stop me and ask me the questions. I will be referring to a couple of books because I've not prepared the stuff for it. I mean, this is very basic, so I'll be going with the flow of what I've seen in certain books. I will introduce some very important concept called excuse me. uh, np and n into 1 minus p, which is how you calculate the what is that called? Um, Shucks, I'm getting old. I'll tell you what it means when we come to it. The name is on my tongue, but I'm not getting it. So I will introduce that very important concept because that will help you understand few of the things that might kind of look very Dominic to you, especially the box plot and all those things. Let's get started, right? So you have the data. Data can be basically categorical. So categorical and the data, the other can be numerical, right? Let me just switch to the view to the. I'm referring to your textbook here, just so I know that I'm covering whatever is in your textbook. Okay, so this categorical data is essentially it tells you about you might be categorical can have uh, by bivariate actually. Let me just call it uh, without attaching any meaning to it. Just let me call it bi or multi and numerical. So when I say bi, basically it's a yes no, right? Yes no, plus one, minus one, 0 or true false, so on and so forth. It could also mean male female, all those that get into categorical variable. And if you have multiple categories, you could be having let's say probably a boomer, Gen Z, Gen Alpha. So you could have those categories also. So these are categorical. There is no meaning attached to it in the sense that they are not, it does not tell you anything about um, except for that someone belongs to this category. It does not really give you anything in numerical terms. The other thing is numerical. In numerical, you have discrete and you have continuous. What is the meaning of that? There is a very important concept which even if you're not from mathematics background, you will understand. Discrete is basically you have 1, 2, 3, 4, so on, so forth. Well, it could be something else also. It could be some other numbers also. Continuous is basically you have 1.45326. And when we say this, so what is the example of it? Example is I'm saying that tell me the number of fruits in the basket, and that's a discrete number. Continuous would be what is your weight, and the question could be, hey, my weight is 45.0, but that is because the sensitivity of the machine is basically to measure only, let's say, 0. It does not have the sensitivity to measure to infinite degrees, infinite decimal places, and it could have been actually 44.999, something like that, right? If we could measure it, and that is why it is called continuous one. Anything which deals with time, with value of the currency or stock value is also continuous value, except that we just make sure that we round it off to 2 places of decimal. That's why it is looking discrete to us. Any questions so far in understanding what are the different types of data, categorical and numerical? Is that okay?
Can you give me some more examples of discrete and continuous? Like two more.
Sure. So uh, discrete is number of yesterday we discussed number of patients visiting. Discrete is tell me which industry are you in?
I'm from consulting,
You're
so
from consulting,
I have
right?
multiple industries.
Okay, so in consulting, right, you have number of clients. Okay, number of clients is the number of clients will always be discrete for you. Number of client proposals will always be discrete for you, right? Number of project requirements will always be discrete for you. Give me an example of a client in any one particular field, and then we'll go further.
So let's assume there is a manufacturing company which produces, let's say, cars.
Number of cars manufactured in a year, or in a month, always will be a discrete. And why it is important is because I can use a discrete random variable to do multiple things. Right now, we don't have to go that far. We are just saying this is very, very basic, that this is the data can be considered as discrete or it can be considered as continuous. And did you get a feel of what discrete really means now?
Yes.
Right?
Yes.
And continuous continuous would be what is the lead time? Sorry. Actually, what is the lead time from end to end? What's the lead time? And that time, you might be defining it as say 7 days, but actually it could be 6.45238 and also many hours or days and hours and minutes and all those things which you cannot measure. It's your limitation to measure it rather than the fact that it is discrete by itself. You are discretizing it by your own definition, right? Um, the amount of waiting time you have to do at a hospital, if you were to measure it, you can go into seconds, microseconds, so on and so forth, right? Zeptoseconds and all. But so that is the continuous part. Continuous never stops. What is the temperature today? It can never stop if you start measuring it. Now, what is the distance traveled? A very good example, intuitive example for me to tell you is, um, you have 2 points, and can you tell me how many points are there between these 2 points?
Can you just repeat the question?
You have 2 points, A and B. How many number of points are there between these two?
Infinite.
Infinite.
It is not countable.
It's not countable,
Yeah.
right? So you can divide it to half, then keep on dividing into half, keep on dividing into half, keep on dividing into half. You will never you will never make it a zero, right? So that is what continuous really means. Does this give you an intuition into what the data is, what continuous and discrete data means?
Yes.
Okay. So now let us go into what is a nominal, what is ordinal. We'll go into that now. And if you just follow the book after this class or probably tomorrow, it will make a lot of sense. That nominal is something which just is, so um, you are saying something is nominal, which basically means that nominal is basically okay. Nominal is essentially stands for name. So you are saying, this is like a category. So the book has a very good example. It says which which cellular company do you use, AT&T or Verizon or something else. So these are just nominal. Being part of one or being part of the other has absolutely zero impact, or does not give you any information about the other person. And do you need them? Perhaps yes. When you're doing categorical, probably you need it, but otherwise it really does serves no purpose, right? You cannot. More importantly, let's assume that in your coding, if you are a coder, you would say AT&T, let AT&T be represented as 0 if you understand how structs or something is defined. So AT&T is equal to 0, Verizon is equal to 1, so on. If you define it like that, then you can put some values to it. These are numerical values, but they really do not mean anything. I mean, there is nothing called mean of these values. There is nothing called is 1 greater than 0 or 0 less than 1 or 2 greater than 1. So there is no meaning absolutely attached to nominal. Nominal is just a category. Is that part clear? I cannot see the screen. I'm sorry, because I'm looking at the book also. So I'm trying to make sure that. So let me know.
Yes.
Yeah.
Yes.
So now after this thing, uh, After nominal, you have ordinal data. Ordinal data is data says that it has an order, right? There is an order to it. So you could say that there is the rating of a bond is the ratings are there. You have B, you have I think yeah A. Sorry, you have rating of the bonds. If you do not understand, if you're not from finance background, that's all right. These are the ratings which basically tell you how good a bond is or how how safe the investment is. If the rating of the bond is high, the price will be higher for that, right? And if the this is a risky bond, this is a non-risky bond kind of thing, right? So it tells you something. There is an order, as ordinal says. There is an order, but there is no relationship again between B, A. Again, you do not always ask yourself the two fundamental questions: Is A twice as better as B? No. Is double A twice as better as A? No. We cannot say anything about that part. We cannot compute the mean. We cannot do any of the mathematical things that we want to do over this set. And that is why, but there's an order. Yes, A is better than B, double A is better than A, triple A is better than A. How much we do not know, and how much we cannot compute. But there is a order to it. And that is why it is an ordinal data. So is this part clear? What is ordinal? We have discussed nominal, we have discussed ordinal, right? Now, there are two important categories of data where people get confused a lot. And so one is called interval data. One is called interval data and the other is called ratio data. This is where people get confused a lot. In interval data, you can actually, for example, you have temperature, right? So you say 33 degrees centigrade, let's just say that, and then you say 25 degrees centigrade. Now you can say that 25 degrees and you can say that 25 is less than 33. That is one thing you can say. You could have said that with the probably the bonds also. But moreover, you can say that if I add 25 to 33, I will get 58. Okay. So what you cannot do is so you can do some operations like these. You can actually say, okay, temperature over here is there a question? Okay, you can say that there is a temperature over here is 25, temperature over here is 33. Find the mean temperature. You can do that. You can do a 25 plus 33 divided by 2 and something like that, right? You can do that very much. What you cannot do and what it does not mean is there is no zero. If you remember this point that there is no zero, you will understand the difference between interval and ratio. When I say there is no zero, what it means is that I cannot say 50 degree is twice as hot as 25. It is not true, right? 50 degrees centigrade. This would be actually true in Kelvin scale if someone understands Kelvin scale, but we are not discussing that. Okay, so 25 degrees centigrade is twice as hot as 25 degrees centigrade. That is not true. So you cannot say, you cannot do that, and the reason you cannot do that is because you do not have a zero over there, which makes a sense. Versus ratio, in ratio you can do whatever you want. You can do the mean, you can do this thing, but you can also say, give me just 1 second. Let me just see this thing. Yeah. So you earned a profit of say 5 million. and last year you earned a profit of 2.5 million, and you can say it is twice as much as this is twice as much as 2.5 million. But you did not you did not get the intuition behind zero, and I'll give you an example of zero now. So, for example, the book uses a very beautiful example. It says a newborn baby, for a newborn baby, let's assume the weight is 3 kg, right? And there is another newborn baby whose weight is 6 kg, right? And you can say no newborn baby has a birth weight of 0 kg. We all know that. But there is a 0 which lets us say that 6 is actually twice as heavy as 3. And that is the reason, because there is a 0 fixed scale, and it lets you go in a direction and calculate those ratios. 6 by 3 is equal to 2, which allows you to create the ratio data. So this is the most important point. And by the way, you are not going to get beyond your unit test, in which they might test you as to whether this is a interval data or this is a ratio data or this is that. You will definitely not get these questions in your final exam. These are very simple things. I hope the idea is clear to you as far as nominal, ordinal, and ratio and interval data are concerned. Is this clear so far? I cannot. I'm sorry. As I said, I cannot see my
Yes,
screen.
Anup.
Yeah.
Yes.
Okay. If you have any questions, please stop me. Please ask me. Then, so we have discussed discrete, nominal, ordinal. We'll come to numerical data in terms of bar graph. We have covered numerical data. Bar graphs will come back later on. Very simple thing, but we'll come later. Then we have categorical data. We have covered this part also. So we have covered this, we have covered this, and we have covered this. In the exploratory analysis, what happens is, give me a second. So now when we want to do exploratory analysis, in the sense we want to, there are two parts. One is descriptive, basically which describes the data, right? And we want to understand what does the data look like, or how does it behave, or what does it have. We want to understand that part. How do we understand that part? For example, there is data, and I will take some data. I'll copy some data from here, and let's assume there is a data which is mentioned here. I'll copy it. Give me a second. So there's this data. This is basically the average fuel efficiency in miles per gallon, right? And we want to understand the mean of it. And I think all of you do understand how the mean is computed. But I want to do something else. I want to call it. I want to call this guy. I want to call this guy x1, x2, x3, x4, x5, x. And what is the formula for mean or average? How do you calculate that? Someone. I mean, I want someone who wants to understand these things to answer this part. How will you be?
X1, X2, X3, all will be plus and divided by that sum of the all.
Divided by
Basically,
total number of this thing, right? So average.
the total number of the vertical is a 6. Basically, it will be 6.
Yes, 22.5.
Number of readings.
Yes, plus 23.7 plus 23.5 plus 23.5 divided by 6. Okay, this is how we calculate the average, the mean. So what I've done is I've actually done x1 plus x2 plus x3 plus x4. The reason I'm writing this down is for later understanding, which will be required, divided by total number, which is 6. And this essentially, for those who are not from mathematical background or who have probably lost touch with the mathematics of it, I can represent the 1, 2, 3, 4, 5, 6. I can represent them as variable. I can say that this is a variable xi, where I goes from 1 to 6 divided by 6. Right?
Can you repeat?
Sorry.
Can you repeat this
Okay.
part?
So I called this x1. I called this x1. I called this x2. I called this x3, x4, x5, and x6. Right? 6 data points. Okay. And I what I've done is to calculate the mean. Mean is basically this is sample mean. So sample mean is represented not by mu. It is represented by x bar. Okay, please understand that. Sample mean, if there's a population mean will be represented by mu. If it is sample mean, it will be represented by x bar. Just the symbol that is different. That's all. Nothing more than that. Now x bar is equal to, the mean is calculated by saying add all the elements divided by the number of total elements. So far with me?
Yes.
Right? And because this 1, 2, 3, 4, 5, 6 are nothing but the positions of these data, so I represent that as xi, where I can go from 1 to 6. Basically, x3 means the third element. Is this clear?
Okay.
So sigma basically means add all of them. Sigma is an operator which says sigma is a Greek symbol for addition. Okay. So sigma, whenever you see sigma, that means you are adding all the elements from 1 to the top level at 6 and add all the elements and divided by the total number of elements. If I have, let's assume that if I have someone who is new to this notation, please tell me, if I had xn variables, then how would my formula look like now for x bar?
So it will be like x1, x2 means plus x2, x3 till xn
Till xn
divided by n.
divided by n. Good. So it will be
N.
x1 plus x2 plus so on up plus xn divided by n. Now can someone else tell me what would this notation convert into if I give this smaller notation? How will it look like?
In place of 6, we'll have n.
Yes, sigma I is equal to 1 to n, and n is a constant, so 1 by n, because this n I'm just bringing outside because this n is a constant, xi. Does it become simpler for you to understand how the mean is calculated?
Yes.
Okay. Everyone with me so far?
Yes.
Yes.
Okay. So now we have done the mean part of it, right? Now, so with mean, what happens is, with mean, you want to, for example, your data. Okay, you have data, for example, that what happened with me. Okay. Now you have data which says someone's, let's say I'm talking about income, right? I'm just saying that one employee is earning probably there's a 10K, there is a 20K, there is a 30K, there is a 40K.
Is it to say that mean is the midpoint of all the observations which we have in together?
No, it is not. Mean is never the midpoint. I'm coming to that part exactly. So, okay, so now I'm saying that there are two people. So this is 1, this is 2. These are the employees who are earning their salary. Okay. So consider this, right? This is a graph which has this is number of employees. And I want you folks to answer. I want each one of you to kind of answer it, with mic on or without mic on. And this is the salary in let's say in case, right? And I'm saying there are two employees, or there is a one employee who's earning 10,000. There are two employees who are earning 20,000. There are three employees who are earning 30,000. There are two employees who are earning 40,000, and there is one employee who is earning 50,000. Okay, is this chart clear to you?
Yes.
Now, can you tell me what is the mean salary? By the way, because now here is the important thing. I think yesterday someone talked about it, and this is very important because I'm talking about all the employees in an organization. It by default becomes population, not a sample, because I'm considering every employee, right? And so, what's the symbol I will use?
Weighted average.
No, I mean no weighted. So that's a different thing. I mean, you will be using that, but that's a different thing. The symbol, what's the notation for population mean?
Oh, that's mu.
Yes. We will not use X bar here, though even though they will result in the same value, but we will not use this. It is just notation, nothing else. Nothing else changes, right? So we will use mu because we are talking about all the employees in an organization. That's a population, that's not a sample. If I just consider some employees in an organization, it becomes a sample. Okay. All right. So can someone tell me how do I calculate the mean of it now?
30.
Mean is 30, fantastic. Yes, the mean is going to be 30. Great, but how did we calculate it? Is the question.
Ten plus 20 plus 30 plus 40 plus 50 divided by 5.
Okay, let's say that someone said it is 10 plus 20 plus 30 plus 40 plus 50 divided by 5, and that basically is 10, 20, 30, this is 60, 60 plus 40, 100, 150 by 5 is 150 by 5 is equal to 30, and this is actually the mean, but this is wrong. Can you tell me why this is wrong?
Because there are two people who are earning 20, so like total be 9.
Yeah, so how many total people are there?
270 by 9, 270 by
One at a time. I will let each of one of you finish. Just one at a time, please. Go ahead, Shruti.
yeah, is it like 270 by 9? Because
I do not have a total. I just made it up on mentally. So you tell me, how did you go?
so one employee with 10,000, so 1 into 10, two employees with 20, 2 into 20, and so on. So it gives a total, and then how many employees in total, which is 9. So
Good.
it gives 30.
Good. Okay, so let me do it in a separate way. This is where you will get the frequency part also. So you have an
You can
employee.
also answer it from this graph. It's already mentioned in the 30 and
Yes.
is showing.
Yes. So now there is one employee who's getting 10. There are two employees who are getting 20. There are three employees who are getting 30. There are two employees who are getting 40, and there is one employee who's getting 50. How many total employees are there?
9.
What 3, 3, 6, and 3, 9. Yes. So total employees is 9. So n is equal to how much? 9.
9.
Right? And I will have to do sums. I will have to sum all these up and divide by 9. Is this clear? I will get the mean, right? So 10 plus 20, 30, 30 plus 20, 50, 50, 30, 80, 80 plus 60, 140, 140 plus 80, 220, 220 plus 50, 270, 270 divided by 9 is 30. So the mean is indeed 30. And you can see the graph is actually very well balanced graph, right? It goes like this. So this is the mean. So now we calculated the mean. This is where it also, the formula, you might see this in the question paper in a different form. You can see that one employee got 10, two employees got 20, three employees got 30, two employees got 40, and one employee got 50. And this is basically the frequency, right? So the mean can also be calculated by 1 into 10 plus 2 into 20 plus 3 into 30 plus 2 into 40 plus 1 into 50 divided by 9. Is this part clear? This is nothing but when you added all these 10 plus 20 plus 20 plus 30, you just got the common terms together and multiplied it. Is this clear?
Yes. Yes.
Okay.
Yes.
So this is another, when you see frequency table, this is basically, frequency table is nothing but same as if you just were to write the data in sorted manner, then you will see a frequency table in a flatter format, or you can put it in this way, and you can calculate the mean by just multiplying the number of terms that are happening and dividing by the total number of elements. So this is, we have got the mean. Now someone asked me, is mean the center? Indeed, 30 is the center of the entire thing. If you see the graph, it looks like 30 is the center. But now my question is, why is mean not the center of the data? It's a measure of central tendency. There's something called, there's a term called measure of central tendency. Is it used here? No. So there are measures of central tendency. Measures of central tendency. And these are basically mean, median, and mode. These all measure the central tendency, basically how the data is looking. But mean is not the center. Why is that? Even though we just saw that 30 is the center and it looks like 30 is the center, why is mean not the center? Anyone? And I'm very sure you'll get a question on this one.
Because mean usually indicates what is the you know, what I can say is, let's say minimum amount drawn by someone, or it's like if it is 10, 20, 30, 40, 50, then everyone has got at least 30 marks or something. It shows like that, but not the actual medium point, I mean.
No, the claim is never that everyone is getting. That is not. The claim is that the group group average is this and everyone is okay with it. Like, for example, if you go for a trip, you go on a trip and your car is giving you an average of 10 kilometers and somewhere it's giving you an average of 20 kilometers, you are okay to say that it is an average of 15 kilometers. You are okay with that part. Right?
Okay. But let's say if I say it's 10, 20, 30, 40, 50 and someone has got 90 marks, someone has got 80 marks.
Exactly.
Then at that time, mean cannot find out the exact central value because it's uneven.
Yes. So now what happens is, there is the CEO who is getting, let's say,
Is it because of the outliers in the data set?
Yes. So there is a CEO who's getting 130K, let's assume. Okay. So now how many data points you have got? With this, you have got 10 data points. And your previous thing was how much? It was 270 and now you're adding 130 to it. So it becomes 400. Right?
Yeah.
Right?
Right.
And your mean immediately moves from 30 to 40. Agreed? And do you all agree that the difference of a CEO salary versus normal salary is actually much, much bigger? So this guy could be earning 1300. I mean, I just want to keep it closer to for this calculation. So let me just say this guy actually is getting 1130. And then it makes it 1400, right? And then your mean 1400 divided by 10, your mean becomes 140 just by one guy. And no one is getting 140. Do you see that? No one is getting close to 140 also, except for one guy who has tilted the balance, the mean, in his favor. So for example, now you want to purchase a house, right? And you are new to a city or a country and you want to purchase a house and your budget is like, I'm willing to, you have an open budget, right? And you go to a real estate agent and say, listen boss, I am willing to pay you the mean value of the house in this locality. And the guy says, fantastic for me. I have all the software programmers, all the consulting engineers, all the finance guys living here whose normal salaries are basically 200,000. And then I have a Jeff Bezos and or probably who's a Tesla owner, whatever. He is living here whose salary is probably 400 million, right? And now you are paying because you went by the mean, you end up paying how much? Much more than what you should have paid for that place. Do you see how mean makes a mess of situation sometimes? Has this become intuitive why mean can cause a problem? Is this confusing? Does it make sense?
It makes sense.
Okay.
Makes sense.
So now we have seen that mean is not something that does that. Then what does that? How do we know what is the what are the other ways? I'll come to median a little later. I'll see mode. So in mode, let me just open this local and give me a second here. Okay. So mode, I don't know. So mode basically means give me something which is the most highly occurring thing. So for example, you have some data which says 2, 2, 3, 4, 5. Actually, you know what? Forget it. I had used example previously where I had said one employee was earning 10, two employees were earning 20, three employees were earning 30, two employees were earning 40, one employee was earning 50. What's the modal value here? Mode basically means highest occurrence. So 3 is the highest occurrence. So 30 is the mode value. If I had a distribution which said 1, 2, 3, 4, 5, 5, 7, 9, 6, 2, 1. Can someone tell me what is the mode here?
5.
Sorry?
5.
Okay, 5 is the mode. Anyone else?
Also 5 and 2. Yes.
So 1, 2, 5. This is called multimodal. So multimodal basically means that there are multiple modes in a data set. And bimodal means there are two modes in a data set, and a single mode basically means there is only one data set. So if your if your data set is like this, then it has single mode because this is the frequency that we are talking about, right? So this point is the single mode. If your data set is something like this, then there are three modes, multi-modes. If your data set is something like this, then there are two modes. Is this clear? Any questions so far on modes? What mode does? I am assuming it's a yes because I cannot see the screen again. I'm so sorry. Now we come to median. Median is one of the most important parts of. So in median, what do you do? Let me just make sure that I have the right data set for explaining median. Give me a second here. Okay. So the data set that you have got is 2, 110, 5, 7, 6, 7, 3. For finding the median, you have to arrange this in a increasing or decreasing order. Whatever, you have to sort the stuff. So you will write 2, 3, 5, 6, 7, 7, 110. Okay, and 2 okay. Based on whatever we have discussed so far, what do you expect the mean to represent the data correctly?
No.
And the reason being?
Give the central value.
There is an outlier.
There is an outlier, huge outlier, which will change the mean a lot, right? What's the modal value here?
7.
7 is the mode. Okay. Now median says arrange them in the sorting order and then find the midpoint. So if it's odd number, 3 here and 3 here, then this is the median value. If it's not an odd number, then so if there is, let's assume that there is no 110, or let me add another number 5, 6, 7, 110, and let's say 130. Okay, then find the central numbers. Okay, so these are 4 and these are 4. These two numbers and take their average. So 6.5 is the average of 6 plus 7 by 2. This is the median. Now the
How did you calculate the mode? Can you tell that also?
mode is the most occurring number, right? So that is 7 here. It happens twice.
Right. Okay.
Right? So that is why it is 7. Now 6.5, the definition of median says half the population should lie here and half the population should lie here. That is what we found with 6. 3 people were on this side and 3 people were on this side. With 6.5, 4 people are on this side and 4 people are on this side. So median is exactly the central point that you have for anything. It may not be the part of the value. For example, for that matter, even mean does not have to be the part of the list or the numbers that you have. But median is the actual central point, and median does not care about the outlier. See, I added 130, but it did not change the without having a 110. I had 6 as the median. With that, I had to add another number. It became 6.5 because another number was added. This number was not changed to some other number. If this number was, let's assume that I had changed this 110 to 1100, even then the median would have remained the same. Do you understand this point?
Yes.
So median is a middle point, not an average. It's an exact middle point.
It is the exact middle point. Half of the population lies on this side and the other half lies on the other side.
And can we say mean is the average? Because
mean is average. Mean is what we call average typically. Oh, okay. Median is not average. Sorry, I did not understand. I thought I heard it wrong. Median is
no. Mean, you did the total of 9 people getting salary of 270. So that is something like average formula only we applied. No, total number of employee divided by total salary. So what we got is nothing but an average.
Yeah, mean is equal to average always.
And mode equal to?
Mode is the number. Anyone? What is mode equal to?
Highest
Highest occurrence of a value in a data set.
Okay, thank you.
So mode will always be a number in the list. Mode will always be a number in the list. Mean may not be a number in the may or may not be, and median also may or may not be a number in the list. Clear?
Yeah.
Everyone, is this clear? Mean, median, mode, is this clear to everyone?
Yes.
Yes.
Okay.
Yes.
Okay.
So then, yeah, see that there will be a data which will
Is there a question to me?
find something.
Sorry.
So you are just saying that in number नहीं रहेगा. मतलब mode will always have a number and mean and median may not have number.
Mean and median may not be the number that is part of the list that was given to you.
Okay.
You know. So for example, if you just take okay, let me just explain what I mean again, just so that others also clear. Let's just take three numbers, 1, 2, 3. The and I'll just take 3. Let me just take some other number also as probably 1 plus 2 plus 3 will be 6. 6 plus 2 is 8. So I'll take 2. So the mode is equal to 2. And do all of us agree?
Yes.
It happens twice.
Yes.
It will always be a number in the list. It will never be some other number. Mean will be 1 plus 2 plus 3 plus 2, which is 8 divided by 4 is equal to 2, which happens to be, in this case, happens to be a number in the list. And for median, I will have to sort them 1, 2, 2, and 3. And can someone tell me how do I calculate the median for even number of people?
2 plus 2 divided by 2.
2, which happens to be 2. This is a perfect distribution where if the distribution is perfect, right, 1, 2, and 1, then mean is equal to mode is equal to median. If the distribution is perfect, then mean is equal to mode is equal to median. Okay, you will see this, and this is not very important, but just a good thing to know. Okay. So okay, I think this is done. Let's move. Now, I want to use some other example. I hope I can erase this. I don't know how to erase. I do not even know how to use this software. I need to learn that also. Okay. I will take some other example to do something which makes it easier for me for calculation. This is not a bad thing. Okay, I'll just take 5 then. So I have the numbers which are 87, 63. Please use your calculator and help me because I will not open the calculator here. I will need to add them up. 91, 72, 80. Okay, I have these 5 numbers. Okay. Can someone tell me how do you? Okay, I want someone to tell me who is not familiar with this, with the notation also, to first tell me the notation so that you understand the notation. How many numbers are there? N is equal to 5. And what will be the notation like? For mean,
X.
for mean, this is sample, let's say, so this is x bar is equal to, go ahead. Formula is,
So summation I
okay. Yeah, because this is a constant, always to bring it out of the summation. Sigma,
Right.
sigma is also called summation for those of you who may not be familiar with it. I is equal to
63.
1.
1 to
Yeah, okay. 1
1 to
90.
5.
to 5.
Total number. That's all. What it is saying is you use this guy as a iterator, as a place. I changes place. So this is I is equal to 1 here, I is equal to 2 here, I is equal to 3. This is like an index, right? So this is the notation. Please, if you understand it, fantastic. Because you will see this notation a lot in regression and all those things. That's why. And even now, very, very shortly. Okay. So what's the mean? 87 plus 63 plus, can someone give me the value quickly?
$78.60.
78.6. Okay. So 78.6 is the mean. Now let's do one thing. try to visualize this. 63, let's assume this is 10, 20, 30, 40, 50, 60, 70, 80, and 90. So we have the first 87. This is 1, 2, 3, 4, 5, 6, 7, 8, 9. So 87 is somewhere here. Okay. 91 is somewhere here. Sorry, 63 next is 63. 63 is somewhere here. Are you all following what I'm doing here?
Yes.
Yes.
72 is somewhere here, and 80 is exactly this point. Okay. Now, my point to you is 78.6 is the mean. 78.6 comes somewhere here. I mean, height has no relevance. I'm just saying that it is somewhere. This is the mean. Okay. Please understand this point very carefully. When I say deviation of the data, okay, then I'm saying how much the data is deviating from the mean point. Okay. So let's do one thing. What is the distance between this guy and this guy? How much is the distance between this guy and this guy? How do we find that? This guy is 63.
15.6.
No, that's okay.
Subtract.
Yeah, subtract, right? So I did. So I can. I will subtract from point to the mean. So first one is. Give me 1 second, please. And I will remove this so that I can create a table. And, what was the value again? 78.6, right? The mean value
Yes.
was 78.6. Okay. So now I'm saying the first point is 63. So 63, and I'm saying 63 minus 78.6. How much is the value?
15.6.
Negative 15.6.
Negative 15.6. Okay. Then the next value is how much? 72. 72 minus 78.6. What is the value?
Negative 4.6.
Negative
4.6.
should be 6.6. No?
6.6.
6.6.
Oh, sorry, 6.6.
Okay. And then then after that it is 63, 72. It is 80. 80 minus 78.6. How much is it?
1.4.
1.4. 87. 87 minus 78.6 should be 8.4. Can you check?
Yes.
And then 91 minus 78.6 should be 12.4.
Yeah, correct.
Okay. Now can you please, now these are the distances or the deviations from the mean point of each of these guys. Okay. Now can you please sum this part? Tell me what is the answer.
Zero.
The distance, the sum of the deviations from the mean will always be 0. Is this part clear? Did you, I mean, I can prove it mathematically, but I don't want to go through the formula of it. It is very simple formula. But did you understand what just happened? What you said was, let me use all of these as the base for my mean, for the average value, and then let me find what is the distance of the average value from each of the other points. And because some is in negative, some are in positive, for that reason alone, the distance becomes zero, the deviation becomes zero, overall deviation. Are you getting the intuition behind it as to why this happened? Or do you want me to show it to you and prove it also? I can show it. It is very easy. Let me show you. I think, am I right in assuming that some of you are confused? Some answer will be helpful.
No,
It is clear.
yeah, the concept is clear. Just that would be interested to know it via formula.
Okay. So, what we did was, we did xi minus x bar. X bar is what? Mean, right? Is this correct? And we did a summation of that. Basically, what I'm saying here is, I'm saying x1 minus x bar plus x2 minus x bar. Sorry, not x2 minus x bar, because there are 5 data points, plus x3 minus x bar plus x4 minus x bar plus x5 minus x bar. I've done this. Is this correct? This is what I did here. Do we all agree this is what I did here? Right? Now, let's open the brackets. x1 plus x2. I'll bring all the x1, x2, x3 on one side, plus x3 plus x4 plus x5 minus, I will keep them in one place, x bar plus x bar plus x bar plus x bar 5 times. Is this, did you understand how did I reach from here to here? Is this part clear? I just added x1 plus x2 plus x3 plus x4 plus x5 minus x bar minus x bar minus x bar minus x bar minus x bar. So minus taking out, this becomes, right? Now, what is x1 plus x2 plus x3 plus x4 plus x5? What is this equal to? Is this not equal to, okay, what is the formula for x bar? It is x1 plus x2 plus x3 plus x4 plus x5 divided by how much? 5. So x1 plus x2 plus x3 plus x4 plus x5 is equal to 5 times x1, x bar. Yes or no?
Yes.
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 So this part becomes how much? This part becomes 5 times x bar. Yes?
Yes.
Minus, how many times are x bars here?
5.
So I could have done this with n also, not just 5. I could have done this with n, and it will become nx bar minus nx bar, and the answer will be always 0. So what is important to know is, when you add all the sum up, all the deviations, I'm not talking standard deviation, I'm saying deviations. Sum up all the deviations from the mean, they will always add up to 0, irrespective of how much data you have, how much, whatever mean you get. Is this part clear now?
Yes.
Yes, clear.
Okay. So now, this gives way for a very important thing to say, okay, I want to understand how much my data is deviating. That is something that I really want to know. And how do I know that if you cannot give me that? If I do that, how will I know? So there are 2 ways to do it. One is called, you will come to learn this term. Sorry. You will come to learn this term later, called MAE, which is mean absolute error, and MSE, mean squared error. But this is basically, we are going to now say that do one thing, make all the distances positive. We are interested in finding the deviation. If I add the negatives and the positives, then I'm getting 0. So that is not what I'm interested in. I'm interested in knowing the actual deviation. It does not matter whether the deviation is happening in the north direction, the south direction, or the east direction, or the west direction. I want to know what's the variation, what's the deviation. So what it says is, you do xi minus x bar whole squared and this will give you a positive distance. Okay, and then you add them up. Now, none of these terms will cancel each other. The minuses and the pluses, they will not cancel each other. They will give you a positive value. And when you divide that by n minus 1 for sample, this n minus 1 is because something called degrees of freedom. It's a concept I do not understand fully personally. Mathematically, I understand it from a English. What do you say? I can explain it in English, but it will not satisfy any one of you. Mathematically, I'm still learning why it is n minus 1. So it is so. This is basically what is known as variance. So your sigma square is called variance of a sample variance. And when you do a square root of sample variance, you get standard deviation, which is sigma. So we will in another session we will work out some examples to do that. But is the concept now at least clear to you why the variance uses the square term?
So Anup,
Hmm.
one thing, same thing like what you said, I was going to ask you this question. That n minus 1, that too in the book it's written for sample only it's n minus 1, whereas for population is n. So like if it's when we are determining say in exam, if we are given this kind of a thing, so if we have to determine that this is for a population, then it will be divided by n, and if it is for a sample, then it should be like n minus 1.
Yes.
Okay.
Yes. In English, in plain layman, if it helps you understand, it does not satisfy me, but if it helps you understand, the reason for sample it is n minus 1 is because because for calculating the mean here, this mean you have exhausted all the n variables. So you have to leave one guy unknown so that you do not bias the judgment. I mean, as I said, this will, I cannot probably give you a convincing answer. So let it be. But for sample, it has to be n minus 1. Okay. For population, it is n. Did you understand some part of it as to how the variance calculation came to be and why deviation is not, why there is something called standard deviation different from a normal deviation that we just spoke about? Is this part clear?
Yes.
Okay, so we have covered mean, median, mode, and today we will end the session with a concept called I hope I recollect the term now. Let me just check the book. Give me a second. Percentile, sorry. So let's try to understand what is percentile. So sample percentile essentially is calculated using something called NP. N is the number of data points. And P is the percentile. What do I mean by that? Supposing, and let me take the example from the book. Give me a second here. Yeah, bhai. What's this one? Yeah, take this. Sorry. These are the values. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 plus 3, 18. So n is equal to how much? Oh, so n is equal to 80. Okay. What does NP mean? This is what helps you understand the box plot. It says the pth percentile, right, means that many number of data points. So if you want 50th percentile, right, 50th percentile, then n is equal to 18 into 0.5 is equal to 9. 9 people, and I will also calculate n into 1 minus p. P is always between 0 to 1. So n into for 50%, this will also become 0.5. So this will also become 9, right? What it means is that at least 9 data points should be less than equal to me. Find a data point in this one where at least 9 folks will be less than equal to me and at least 9 folks will be greater than equal to me. Okay? Is the definition clear?
Yeah.
So let's calculate. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. The reason I'm numbering all of them is because of very amazing point. So it says 9 folks should be less than equal to me, and this says 9 folks should be greater than equal to me. Find such a data point. We'll come back to it in just a minute. Let's find 25 percentile. So 25 percentile will be how much? Can someone tell me? Walk me through that formula now with this formula NP. Anyone? Too late in the night?
18 into
18 into
0.25.
0.25.
4.5.
Which is 4.5. And I have to correspondingly also say n into 1 minus p, and that will be 18 into how much?
1 minus 0.25. Yeah.
1
Which
minus
is point-
0.5, which is 2, which is 0.75, which is
Yeah.
3 times 0.25, 3/4 basically. This was 1/4, this is 3/4. So this will be 3 times 4.5. This will be 13, 12, 13.5. Is this correct? Let me know.
Anup, can you please explain this a bit?
Which
Yeah,
one?
but I
Uh,
was
the- The formula part, basically.
Okay, the formula part. So we are calculating. How do we calculate percentile is the question. How do we find which data point is the nth percentile? Okay. So I'm saying that. Okay. You all saw this plot, yes or no? This is
Yes.
the box plot.
Box.
Okay. This is the 25th percentile, the first quartile.
Yes.
This is the 50th quartile, 50th this is the median. The 50th percentile. Yes.
Yes.
And then this is the 75th percentile. Do you remember the box plot? I was coming to that actually. So how do you find, now you are given a data and this is the data 122 to 212. This is in sorted order, right? Now, how do I find 25th percentile point? How do I find 50th percentile point or 75th percentile point? For that matter, any percentile point. How do I find that? That is the whole point. So the definition of it is, the definition of that percentile is that if you are trying to find whatever percentile you are trying to find, let it be P. Let it be called P. P is the percentile. You want to find 30th percentile. Then by definition, it means n into 0.3 points, n into 0.3 data points should be less than equal to that data value, which represents 30th percentile point, and n into 1 minus 0.3 should be greater than equal to the data value which represents this, the same data value. Meaning n into p data point should be on the left side and n into 1 minus p should be on the right side. Does it make a bit of difference in understanding? When we work it out, then you will understand what it means. But does it make a understanding? Yeah. Okay. Yeah. So now let's I want to calculate 20. I don't want to calculate 30th percentile. I want to calculate 25th percentile. So what is it? My question is, which data point represents 25th percentile? So what do I have? N is equal to how much?
N is 18. Yes.
N is 18. Percentile P is how much?
25.25.
0.25. And 1 minus P is how much?
0.75.
0.75. So this is basically 1/4 and this is basically 3/4. So NP is equal to 1/4 of 18, which is 4.5. And N into 1 minus P is basically 3 times this amount, which is equal to 13.5.
13.5, yes, sir.
Is everyone with me so far?
Yes.
So now what it is saying? It is saying at least is very important. At least 4.5 items should be less than equal to the value whichever you choose. Okay. And at least 13.5 should be greater than the value that you choose. So this is the fourth item. Okay. Can I choose 140 as the 25th percentile point? Can I choose 140?
No, between 140 and 145.
So between 140 and 145, okay, that is a fair enough answer. Between 140 and 145 is what he's saying I should choose. Okay. But how are you sure? Okay. So now, okay, let's calculate this part. So if I choose between 140 and 145, what is the other part that is saying? It is saying that at least equal to, right? How do you know that you're asking me to calculate the average of these two? Is that correct?
Correct.
Okay.
Midpoint of these two numbers.
Yes. So you are saying midpoint of that number. We'll keep that in mind. Okay. Now, by definition, how many should be more than this number?
So there will be 13.5.
So 13.5 number should at least 13.5 number should be greater than or equal to that position, that data value. Correct? So let's calculate. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And then you get this guy. 13 is here. This is 13 from the backwards, right? Okay. So can I choose 140? Can I choose this 145?
No, the left one.
Yeah.
So I can choose
Number
this guy.
5.
I can choose this guy.
Yeah.
This guy satisfies the left side also and the right side also. Do we agree?
Yeah.
Yes.
Okay. So 145, this 145 is the 25th percentile point. I don't have to calculate the average because I don't have to go to the trouble because this guy satisfies both the parts. Is that clear? Just a second.
Yes.
अच्छा, meeting में 5 मिनट लगेंगे. Okay. Now, sorry. Now, I want to calculate 58th percentile point, right? So I'll remove this guy. 58th
So
percentile.
if 145, one of the 145 that is on the right side is 13th number, then how it is satisfying the 13.5?
मैंने बोला मैं 5 मिनट में
No,
10
it
मिनट
says
खत्म हो रही है
like greater
तो
than
उसका
equal to
उसका कौन है?
that means at least 13.5 number
Okay.
should be in front. Okay, so the 13th position is that second 145. So that's why we are choosing the left one, 145.
If we choose this 145, which is on this side, then it satisfies the criteria that for at least 4.5 are less than equal to 145, but it fails the criteria that at least 13.5 should be greater than equal to this number. Okay.
Okay.
Now I want to choose 58th percentile point. So now what is 50th percentile? How do I calculate that? N is equal to N is how much?
80.
And P is equal to
0.5.
0.5.
So 1 minus
Point-
P, 1 minus
0.5.
P is also 0.5. So answer will be it will result in the same.
9.
1/2.
Yeah, so it will be 9. And P is equal to 9. And N into 1 minus P is also equal to 9. Okay. Now, what is the definition? Other than Subhajit and probably Mayur, can someone tell me what is the condition that I want now to be satisfied?
That 9 should be below and 9 should be above the.
At least 9 data points should be less. My voice is
Less
recording.
than?
Mayur, can you please go on mute?
Yeah, it should be more than 162, 9 number, at least.
No, we'll come to which number is that. But what it says is that at least 9 data points should be less than equal to whatever value you choose.
Okay.
Right?
Then it's a 162.
So 9 is here. So 9 is less than equal to this guy satisfies the condition that at least 9 are less than equal to this. Okay.
Yeah, it's satisfied.
And this guy, what does it say? 9 data value should be greater than equal to 9. Okay. So 1, 2, 3, 4, 5, 6, 7, 8, 9. This is 9. Okay. So if I choose 157, here is the thing. If I choose 157, does it satisfy the left side condition? Yes or no?
No.
It does. At least 9 are less than equal to 157, which is
So less than equal to. Oh,
Yeah.
sorry.
okay.
But at least, yeah.
At least 9 should be less than equal to that, and at least is basically that number, right? So 9 it satisfies. 157 also satisfies that at least 9 should be greater than equal to my value. Correct? Is everyone with me? I mean, are you folks following the other folks? Yeah.
Yes.
But there is also another. So this number satisfies, but there's another number called 162. Let's see that. Are 9 numbers less than equal to this value?
Yes.
And are 9 numbers, at least 9 numbers greater than equal to this value?
Yes.
So now you have a tie. You have 2 numbers which qualify, and now you go for their average. You say 157 plus 162 divided by 2 is my average. Can someone tell me what is the average of this one? I do not know. Probably 159, 160? No, not 160. 150, 159.5?
159.5, no?
Yeah, 159.5, I think it should be. Okay, so now this is the 50th percentile point. And if you calculate the median of this guy, you will actually get the same value. And that is why in the box plot, this is the 50th percentile point. Do you understand how do you calculate these points now? If given the data, can you find out which is the 50th percentile, which is the 25th percentile, which is the 75th percentile? Or do you want me to repeat this? Who wants me to repeat this? Please go ahead.
Please repeat once more.
Which part from the beginning or
No, the 50th percentile part.
okay? 50th percentile part. I will give you a rule. The rule is this: if you get from NP with the application of NP, if you get an integer, then it will be the average of the 2 points. If you get an integer here, whole integer, then you will have to average the 2 points, the 9th and the 10th position. And if you get a fraction, then you just have to take the next one. That's all. That is again, there's a mathematical proof for that, but I will not go into that. So 50th percentile, what we said is, I want the, okay, first someone please, other than Sobhajit, Mayur and Vishal, you can answer this. What do I mean by when I say I want 50th percentile point here? What is it that I want?
That 50% of the numbers should be below that number and 50% of the numbers should be above that number.
Absolutely. I have some numbers. These are my numbers. There are 18 such numbers, and I want 50% of the numbers to be, find me the data point at which 50% of the values are less than equal to this, and at least 50% are greater than equal to this. This is what I want to do. This is what I want to find. So how do I go about finding it? What is the formula? Simple formula.
N into the percentile. So
N into
it's
percentile, which is
10%.
2.5. N is how much? 18 into 0.5 is equal to how much? 9. And I have to also find n into 1 minus p, because it is 0.5, it will be the same. It will also be equal to 9. So I have to find a data point, find a data value such that there's a mathematical process that 9 data points, at least 9, sorry, this is at least 9, okay. At least 9 data points are less than equal to this value, this data value. So I say, okay, 9 is fine. Find, there's the index 1, 2, 3, 4, 5, 6, 7, 8, 9. Ninth number qualifies. This number qualifies. At least 9 are less than equal to this number. Now, what's the other condition? N into 1 minus p is equal to 9. 9 such that at least 9 data points are greater than equal to this data value. And I say, okay, fine. From this 157, 1, 2, 3, 4, 5, 6, 7, 8, and 9 actually are greater than equal to this. So I'm good here. And but the other problem is, because it's an integer, I told you a rule, it's an integer. That means there will be another number which will also satisfy this equation. 162 also says the index is 10, and index is 10, and there are 9, at least 10 data points which are less than equal to this number, which is greater than 9. And again, 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 data points which are greater than equal to this. So this guy also qualifies. 157 qualifies, 162 qualifies, and I will need to take the average of these two, and that is my 50th data point, 50th percentile number.
Anup, I have a question here.
Yeah.
In this respect. So in that case, when we are taking an average between 157 and 162, that's not a exact data point in our
Yes.
data set that we have
Yes.
mentioned.
Yes.
Am I right?
Yes. That is where I said that 50th percentile is always the median, and median does not have to be the number in your list.
Okay, you said median.
Anup, can I ask something?
Yeah.
Suppose I had given some exam and they are saying 75 percentile is the passing score. So it means they will only pass the top 25% student.
They will pass the scores. They will not pass 20. it depends. There can be two meanings to it. One, they will not say, they will pass the data points, all the data points which are greater than equal to the 75th percentile. It does not matter. It does not happen to be that many number of numbers. I do not know whether it will be the number of numbers, right? But so 25% data values will have to be greater than your number.
25%.
Considering there is a strength of 100 people in the class. So we have a population somewhere, okay. So will that be the same way? So what I was also just about to ask this question. So in a class of 100 people, if the 80 percentile X has got a 80 percentile, does that mean that there are 20 people, or including X, there are 20 people who are above 80?
Because you have taken a very special case of making it 100, percentile happens to fit the percentage. Understand?
Okay. In that case, it will be similar to the percentage.
Yes.
So in this case,
because you have chosen 100 as the base.
okay. But getting some odd number or getting a different set of data where there are multiple observations, so this will not work in that way.
Yes. And you saw that,
So,
right?
Got it. Got it.
Look, you said me that I should be at least above 25 percentile. Means in a batch, I should score more than score of 25% population. Does it mean that 75 percentile?
Yeah, because you are talking about the last quartile, right? The last quartile, there is no there is no 100th percentile, right? Because it is the last quartile, right?
Correct.
So when you are saying everyone below 75 percentile will fail, then obviously you will have to be in the top 25 percentile.
Okay. And
so here top 25% doesn't mean that the number of the strength would be the 25% of the population. It can be.
It can be.
It may vary. Basically.
Yeah. It will
It
be
can.
It will be n into that, right?
Yes. 25% top percentile doesn't mean the 25% population of the data set.
Yeah.
Okay.
So clear with this one, this stuff now.
Yes.
How
Thank you.
So this is how the box plots are. So I've actually covered a part of this one. I'll go with box plot a little bit more in terms of making sure that what are the whiskers and what are the outliers and how do they present them. But we have started our intuition towards how box plot is constructed, right? Does it make sense now? Any questions?
It's clear.
Okay.
Yes, sir.
All right. So I think probably one more session, sometime later, sometime next week. I will probably cover I think someone has a test this weekend, right? Some batch.
Yeah, we have it.
Okay. I hope this helps you in understanding, because tomorrow we have a session, but I'll be talking about random variable, and I'll be talking about random variables and probability distribution tomorrow, which will be in the normal flow of things. This was a more basic thing. So I'll be talking about that, but I hope this helps you.
Yes, this was really helpful.
Anup got clear many of the concepts and ideas.
More welcome. Absolutely, anytime. Feel free to just put your questions on this thing.
I will reach you if anything comes up.
Absolutely, feel free. No worries at all. Yeah. All right. Okay. Cool. Thanks so much. Good night.
Thank you.
Thank you.
Thank you.